Okay, let's work through a problem. I'm using the same numbers that I used in the YouTube video about the speed of a wave on a string. And I just want to go ahead and calculate the fundamental frequency and its corresponding wavelength for that string. And then just to use the equations, I want to know what's the frequency of the fifth harmonic and its corresponding wavelength. That string was under a tension of 707 newtons, and the string was 3.7 grams of mass over 150 centimeters of string, but on that string only 65 centimeters were free to vibrate. And so when I get to my calculations down the road, L, which is the length of the vibrating portion of the string, is only going to be 0.65 meters. All right. So again, it's like you just bought a brand new guitar string. It's 150 centimeters long. You determine its mass, and then you go ahead and you attach it to the guitar and you snip off all the other ends. So only 0.65 meters, 65 centimeters, is actually vibrating when you pluck the string. First thing is to figure out the value of mu, and you have to be, remember, in kilograms all over meters, all right? Kilograms over meters. And we've done this before. And that came out to be 0.00247. 0.00247 kilograms per meter. And then to calculate the value of V, let's just change colors because it's getting a little confusing. To calculate the value of V, the speed of a wave on that string, remember it's tension all over mu. And again, we've already done this, but just to repeat, that's 707 all over 0.00247, because the tension is right here. And that came out to be 535 meters per second. 535 meters per second. So given that wave speed and the length that is actually oscillating for the string that's free to vibrate, what's the wavelength? That's the first thing. That's the easiest thing to find, because you know that for the fundamental, L equals 1/2 lambda. Okay, so that means lambda equals 2L, which is 2 times 0.65, which is 1.3 meters. That's the wavelength corresponding to the fundamental. What about the fundamental? The fundamental frequency? Well, V equals F lambda. If I solve for, I can put in my numbers and solve. I'm going to solve for F. So F equals V over lambda. Again, I'm using a 1 here because this is the fundamental. Remember, the V doesn't change no matter which harmonic you're talking about. So V is 535. 535 all over 1.3. And that is, let's see here, 535 divided by 1.3 equals 412 hertz. Remember, we're dealing with frequencies. So 412 hertz. So that means for the fundamental, that is going up and down, oscillating 412 times per second. Now, what about the fifth harmonic? Now you can go ahead and, using this equation here, calculate the wavelength directly. There's two ways to do this. You can find the wavelength first and then find the frequency, or find the frequency first and then find the wavelength. I'm going to find the frequency first. It's easy. To find F5, just multiply 5 times F1. Remember that the frequency of the fifth harmonic is 5 times the fundamental. The frequency of the nth harmonic is n times the fundamental. So this is 5 times 412. So I have not rounded my answer in my calculator, so it's a little less than 412. So times 5 comes out to be, well, it rounds up to 2,058 hertz. 2,058 hertz. So now there are two ways to find the wavelength. I can use V equals F lambda. That's what I'm going to do here. V equals F lambda, but that's the fifth harmonic times its corresponding wavelength. We know that the speed is 535. We just calculated the frequency as 2,058 and solve for the lambda, the wavelength of the fifth harmonic. So that is going to be pretty small. I get 0.26 meters, 0.26 meters. 0.26 meters. That's the wavelength corresponding to the fifth harmonic. You could have done that differently. Let me get a different color. You could have used this equation for L. Remember that L equals N over 2 for the nth harmonic. So L would equal 5 halves lambda for the fifth harmonic, or lambda equals 2/5 L. So 2/5 times, remember L is 0.65. It's not 150, it's 0.65 because only 0.65 is free to vibrate up and down. Not all of it can vibrate. Only 65 centimeters, 0.65 meters, is free to oscillate up and down. That's why I'm using that number as opposed to that one. So what's 2/5 of 0.65? And hopefully it's the same answer. Otherwise I made a mistake. God forbid. So, what do you know? It's 0.26. The world is not going to end today, at least not because of this. 0.26 meters. Again, you don't have to do it both ways, just pick one. The end.